Hi there, and today we are doing AP Chemistry Lab number 3, and the goal of this laboratory is to be able to separate two substances that have been mixed together. So you can see in my little container that there is a mixture of sodium hydrogen carbonate and sodium carbonate. They've been mixed in here, and our goal and our purpose of today's laboratory is to be able to work out the percent of each substance in this particular sample. So we're going to use some basic stoichiometric principles to be able to go through and problem solve this. Usually this is an inquiry lab, but I'm going to step you through it today. And what we're going to do first, and this of course is just a demonstration, is I would weigh my crucible on the balance and take a reading for that. And then I would write it down, so you can see that I've already previously done this. So my crucible was 37.558. I would weigh my lid on the balance and write that down, okay? And then I would put a sample of my mixture into the crucible, okay? And I would place it in. And you can see there's a small sample there. It's just a white crystalline substance. And what I would do is I would zero it and weigh the substance with the crucible and the lid. And I would write that down, and you can see that here is 38.306 grams, okay? So what I'm going to do once I've done that is I'm going to go through and turn on my gas, okay? And I'm going to place my crucible on the top with a lid, just a little bit of jar, and I would heat that up, and I would wait for some period of time, and I would wait, and what would actually happen is that there would be some gases that would be evolved from this particular heating up. Okay, and I would wait until I would be sure that most of that gas would be evolved. So after I've heated it for a period of time, I would remove the crucible with tongs. I would place it on my heat-proof mat, and I would wait for it to cool down. Once it has cooled down, and I'm just obviously demonstrating because this would take a period of time for it to cool down, I would go back, I would place in the balance, and I would reweigh the substance, okay? So I would do that 1 or 2 times, so that my first heating, I got 38.061 grams, okay? So this might take 2 or 3 heatings, but after my second heating, I could see that basically there wasn't a lot of change going on. So I've managed to, just by looking at the results, successfully make the assumption that I've managed to evolve most of the gases from this substance, okay? So what you're actually going to do for this particular laboratory, and there's a variety of mathematical skills in this, and if you notice the assessment sheet that I've placed on your document for this particular lab, you're going to have to go through and perform a variety of mathematical calculations to be able to come back to this value of what this original mixture actually was, okay? So we're actually trying to find out what the percentage of these two substances is mixed in this container. So you can see my very first step if I'm looking at doing calculations is to write the chemical equation, the balanced chemical equation out. And you can see that these were my 2 gases that were evolved in my experiment. So you can see that I've tried to demonstrate that to you. What you will need to go through and work out is what the total molar mass of these 2 gases were. You'll need to place that down here in your calculations in the bottom, and you'll need to work out the percent composition. You should have gone through this particular skill in class. Once you've been able to solve that, you're going to need the result from your crucible after heating 2 or 3 times to work out the mass in grams that you have left over from evolving these 2 gases. You're going to place it into these boxes and multiply by the decimal of the percent composition that you've discovered from this particular calculation. Okay, so So that skill is using percent composition to solve for grams. Then you're going to move on to step 3, which is solving for the moles. We did something similar in the last experiment. Okay, so you're going to get that value and move it across here and multiply by the molar mass. And then you're going to look at the mole ratio to be able to solve the moles. So if you look back and refer to the chemical equation, you can see that you would get your mole ratio information from the chemical equation. Okay, so you can see that I've actually set that all up for you so you can step yourself into that. Now I've left questions, the skills for 5 and 6 blank, because if you've got to this point you should be able to think about how you could do the rest of the math to work these 2 last steps out. Remember, you're aiming to go back and work out what percentage of each substance you have. Is it 50% HCO3 and 50% Na2CO3? Is it 60-40? You don't know. You're aiming to find out what those 2 percentages are. So what you'll do is you'll go through, and when you submit this to me, you will do your own flowchart. It could be that you do something similar to mine. You could color code it. You could work going down a page. I've kind of done mine as a cyclic process. And then you will read that there's information about the concept of green chemistry. So this really is authenticated, this experiment, because when you work in industry, chemists are continually working with mixtures and thinking about how they can safely dispose of them, or how they can minimize loss of product or reactants. And so they use stoichiometry to be able to problem solve many of these problems. There is a link on your document that talks more extensively about green chemistry. You can read the information and try and find the linkages between what we're doing in this experiment and what's currently happening with green chemistry.